Okay, so in this lesson we're going to look at how to graph inequalities. And the inequalities we're going to be graphing in this lesson are going to be written in slope-intercept form. Now let's review inequalities for a second. At the beginning of this chapter, we talked about inequalities in this form where we had maybe 2x plus 8 is less than or equal to 10. And we solved this, and when we solved this, we ended up getting a solution like x is less than or equal to 1. And we graphed that on a number line. And we remember when we graphed that on a number line, we would use, in this particular case, a closed circle at 1 and an arrow pointing to the left, indicating that all of our solutions are including 1 and everything to the left of that. So we used a closed circle if it was included, or if I had an answer like this, x is less than 3, we'd use an open circle at that spot to show that that point is not included, and then an arrow in this case pointing to the left. So in this particular lesson we're graphing inequalities where we have both an x and a y. So we're going to be able to graph these on a coordinate plane. So to do that, and again these are going to be in slope-intercept form, to do that we start by finding our y-intercept. Our y-intercept for this case is at -1, and it's got a slope of -1/3. Meaning that we go, remember our slope is rise over run. And we rise up if the slope is positive, we rise down if the slope is negative. And then our run always goes to the right. So the fact this is a -1/3 tells me that I go down 1 to the right 3, down 1 to the right 3. Now the only time we ever go to the left is if we go backwards. So here I want to find some points to the left of my y-axis. So I'm going to go, instead of going down 1 and to the right 3, I'm going to do the opposite, up 1 and to the left 3, up 1 to the left 3. Now, before we connect these with the line, there's something important that we need to talk about. And that's what kind of line to use. If it's ever less than or greater than, we're going to use a dashed line. The reason for that is the points are not going to be included on this line. Just like when I graphed a second ago and we talked about if I had y is greater than 3, in this case I would have an open circle at 3 and we'd be including the points to the right of it. So we would say that point 3 is not actually included, but all the points to the right of it are. Well, this is saying the points on the line are not included, but now I'm going to shade in a region. That's the thing that's different here, is there's two things that are different from graphing a regular line. One is the line we use, sometimes they're going to be dashed, not solid. And two, we're not just graphing a line, we're graphing a region. In this particular region, the fact that it says greater than means that I'm going to shade above the line. Now this trick of being able to shade above the line only works when we're in slope-intercept form. So let's talk about that for a second. Let's look at this table. So why don't you copy down this table in your notes, and while you're doing that, I'll explain what this means. So in the middle here we have our different symbols, our less than or equal to, greater than or equal to. If we look at this vertically, that's going to confuse you here. But as you look at this vertically, we use a dashed line. If it's just less than or if it's just greater than, we're going to use a dashed line when we graph it. If it's less than or equal to or greater than or equal to, we'll use a solid line. Now here's the key. If we ever, we can only use this trick when our equation is set up to be in slope-intercept form. In the next video, we're going to talk about what to do if it's in standard form. But if our inequality is in slope-intercept form, we can shade below if it's less than or equal to. We could shade above if it's greater than, or greater than or equal to. So let's make sure you get that in your notes. So you might want to pause this video so you can get that finished written. But let's use that now again as we talk about this other example. So this other example here is y is less than or equal to 6/5 x minus 5. Again, we start out doing the same thing. My y-intercept is -5. My slope is 6/5. 1, 2, 3, 4, 5, 6 to the right 5. Always ask yourself, do I use a solid or a dashed line to connect these? For this one, we would use a solid line. Now we ask ourselves, do we shade above or below the line? The fact that it's less than or equal to means that I would shade below the line, just like that table says. Okay, why don't you guys take a couple of minutes now to graph these last two examples. So why don't you copy these down, pause the video, and then hit play when you're ready to check your answer. Okay, so let's check. You should have gotten these as your answer. So just to talk about this again, here your slope is your y-intercept is a positive 3, so we start there. Your slope is 4/3. Now when you try this, if you go up 4, 1, 2, 3, 4, over 3, you know you're going to be somewhere over here. But instead of just guessing, you can always go backwards. So remember, to go backwards, we would go down 4 and to the left 3. Down 4 and to the left 3. And then we could connect them. And we would shade above, and we would use a solid line to connect those points. And then we would shade above because it says greater than or equal to. With this one, your y-intercept is a positive 1, so we start there. It's a slope of negative 4. That means it's negative 4 over 1. So I go down 4 and to the right 1. If I go down 4 to the right 1, I'm going to run out of space, so I could go backwards. I could go up 4, 1, 2, 3, 4, and to the left 1. Again, it's greater than, not greater than or equal to, so we use a dash line. And the fact that it's greater than tells me I'd shade above the line. So hopefully you can see how easy this is when we need to graph inequalities when they're in slope-intercept form. In the next video, we'll be learning how to graph them when they're in standard form. So good luck on that first part of your assignment.